You crazy mother. Yeah.
It's just BurnEye.
Hey, BurnEye just like last week, huh?
Weekend at BurnEye's.
Hour in. So this is a good time where we'll play here a little bit of the Terrence Howard interview with the Demystifying Science crew, and they're awesome. Need to do another episode with them. Shiloh wins. I don't want to get the names wrong, but great people and great interview they did with Terrence here. And there's a couple parts I wanted to try to cover here. They actually get some real science out of them. So let's see. Oops, what the heck? There we go. Let's see if this works.
Of pressure conditions between neon and helium squeezing on each other. These things, this is what makes us happy. But let me do this last one. Go on. So now, whereas before I took 4 of the linchpins like this to make this, took 4 of these to make this. With the noble gases, it only takes 3 of these structures, and they will also complete. I don't know, I did that on the wrong angle. I need to overlap them so that they're there. 1, 2. And then once the third one comes in, so now this structure, if you can look at the vortices, can you see this? If you look at these vortices on this,
the vortices are the axes of
these
the
points
linchpins.
that's sticking out. I would say the
protrusions.
Protrusions. Yeah, let me use your linchpin since I just crashed mine. If you look at those in comparison to the normal matter, these having the 3.
The reactive matter.
Yeah, the reactive matter.
A little bit higher if you can.
Yeah, the reactive matter. Now you see why they can be around each other, but they cannot bond because of the edges of them, the geometry of them doesn't.
So what he's actually saying right there, I believe, is crucial and valid and explains a couple of the different states of, the reactive red hydride states and the blue oxide non-reactive states of the materials that I'm making, potentially. But yeah, just interjecting that little point there. Should be more explanation coming up here to make it all make sense.
Not allow them to interact because these things are capped, whereas the linchpin, it does not have.
Linchpin isn't closed. Like the linchpin is actually a bonding structure.
It's a bonding structure, whereas the noble gases are permanent structures. And like in my model and what I was trying to explain on, and what Walter Russell explained, and me taking Walter Russell's model, Walter Russell explained that the noble gases sit on the edges of, as the edges of a system. And when the noble gases are squeezing on each other between neon and helium, they're twisting on each other. They maximize into carbon. There's a that's the maximum point of pressure in carbon. Then the secondary point is the boron and the beryllium. The other point is the No.
You brought a periodic table with
got
you.
one right
Yeah, no,
there
it
if
was
you
the
wanna see.
boron. It's the boron and the nitrogen becomes a secondary bond. The beryllium and the oxygen is the third, and the fourth one is the lithium and the fluorine. Those are
All right, pause that again there so that we can, there we go, show reference to what he's talking about. And what he's talking about is referencing Walter Russell's periodic table, and that, oh man, why do I have to load the crappy quality one? Sorry, bad pixelation on this, but basically that one of these sections has the metals and the salts that he's talking about, the elements, or maybe it was the gases up top, but that they're on these alternating positions of balance of scale, and that's what gives them their properties and characteristics in the different subgroups of them, and that Walter Russell's harmonic octave geometric system makes chemistry make more sense, makes the reactions make more sense, and that from this geometries he was able to come up with his other geometries. My apology, trying to find right. Oh, we're going way off. We're going way off what I was trying to find. Never mind. Back to Terrence Howard here for a minute.
iterations of pressure conditions between neon and helium squeezing on each other. These things squeezing and pushing on each other generate these smaller bubbles that we call the normal matter. But it doesn't have, like we said with the water, the smaller bubbles that don't have the same structure as it.
One thing that I think might confuse people too is that you're working under the impression that there are in the Greek sense, atoms that are smaller than hydrogen as well, right? So the fundamental of this harmonic system that you're proposing starts before the actual.
Okay, there we go. And that was a great place to pause it. So now I can actually show the proper reference of, now, here we go. They were talking about the specific elements in their areas, and now Shiloh brings up that there's these particles that are below hydrogen and that must exist according to this theory, the scale, and Walter Russell below the visual or comprehensible solid particle states that we see in our dimension, and that they do exist, they must exist, and he explains coming up a bit of it. And I do suspect this is most likely the correct model, and I do also love that they're speaking in terms of bubbles and fields interactions with all of this.
Sure.
Yeah, there's like the alphanon, the gammanon, the other
alphanon,
pieces.
alphanon, betanon, gammanon, then helium. But
then hydrogen?
Hydrogen behaves and sits in the same position as carbon. It's a plus and minus 4, the same way that carbon is a plus and minus 4, and carbon sits in the middle of the octave, the same way that silicon sits in the.
All right, we're gonna bring back, show what he's talking about again. Here we go. So what did he say? He said, so there's helium right here, right? He's saying it's the first hydrogen has to sit on the negative 4 plus 4 negative 4 scale, just like carbon does here, and just like silicon does here. And because of that, it gives them a whole bunch of other characteristics and explains why carbon can turn into diamonds and silicon into quartz and everything else about them, and that they are essentially larger building blocks in the structural harmonic geometry of matter. So with that, here's his explanation.
It perfectly between the two noble gases. So therefore, there must be a noble gas if hydrogen has the same spectral lines as carbon and behaves in the same way as carbon and silicon and cobalt, and all of them have a noble gas in front of it and noble gas before it, then hydrogen should also, if it has the same spectral lines or same tone as carbon, then if A is equal to B and B is equal to C, then A is equal to C. So hydrogen needs a noble gas that it's pushing up against. So that's what Walter was talking about, even though we can't perceive it.
So we looked into this tonal relationship. We pulled up the NIST data for all of the spectral lines. There, by the way, are dozens of them for each one of these elements.
So theoretically, if you take something like hydrogen, it has an infinite number of spectral lines that are possible depending on how much energy you put into it. So the reason that it's difficult to look into a statement that says that these substances are harmonic versions of one another is because you can't figure out where to start. And so
in order to propose a harmonic relationship, you have to understand the fundamental. And if we don't know what the fundamental is, it's a difficult claim to evaluate.
Yeah, so basically, like,
perhaps impossible.
What we both did is we went through, we collected the spectral lines for hydrogen, carbon, nitrogen, oxygen off of NIST, and you get this table, and you can pick, persistent lines, strong lines, whatever lines. And we picked the same ones from each kind, turned them, and you get them as angstroms off of NIST. Divided by 10, you get nanometers. And so nanometers, in order to get to frequency space, you have to divide the speed of light by the wavelength of your light. And then you get a frequency out of it. And then if you're talking about harmonic relationships, those frequencies of the light spectra should be multiples of one another, right?
Integer multiples,
right? So an octave relationship is like 1, 2, 3, 4, 5, like up to whatever.
Well,
1 technically isn't an octave, it's the identity. But yes.
Well, I was going to say you get the fifth and you get all these other intervals that emerge.
You do from the overtones.
Yeah.
But the thing is that I couldn't really find that relationship. There's definitely some lines that are multiples, like whole number multiples of other lines. But it wasn't like every single line in hydrogen is a whole number or gives a whole number multiple of that frequency in carbon. And I don't think that means that there is not a harmonic relationship.
What's the tone of carbon and what's the tone of hydrogen?
Well, so I can pull it up.
It has technically infinite number of tones depending on how much energy.
But the base color,
the strong lines.
The base color that's generated on the spectral lines for hydrogen. What's the color of that in comparison?
I can tell you actually there's like 15 lines that you look at, and when you look at these like 15 or 16 different lines, you get just a collection of.
Yeah, read a couple of them if you got it open.
Yeah, hold on one second.
We made a little spreadsheet yesterday.
We did.
So in here, Terrence is about to call out the falsity of academia in the information that's provided in regards to this, and that they hide the actual resonant frequencies and true color charts of the elements. So just another minute or two for him to get to that point.
All right, good little scientists put together a spreadsheet.
Yes.
We
Okay,
actually called up this lady who studies this at Skidmore, and we found she hadn't. We needed to go one step further, so we put together this table.
so basically, this is over here on the left is you have hydrogen. And NIST gives you a bunch of data. So you have intensity, you have wavelength, you have the atom that it is the spectrum of, and where they pulled that.
Did they give you the prime resonant frequency off of it?
No, that's the
Nobody
thing. Like they don't
knows.
have
No,
one.
they do know.
Oh, frozen. All right, there we go. Yes. No, they do know, and it's a key part of this technology. It blows open this cold fusion technology and harmonic scaling, and yeah, it's that it's hidden intentionally. They won't give it, and they most likely know it. And yeah, we'll just finish off the last little clip here, or portion of it, and I fully agree with Terrence on that.
What made me go into trying to figure out, okay, I was like, well, let me define the prime resonant frequency of elements. I called up UCLA, I called up UC Berkeley, and I was like, hey, I wanted to talk to the people in the chemistry lab. And I asked them, I was like, I'm trying to find what's the prime resonant frequency of the element. They wouldn't give them to me.
Well, I don't think they know them. Like I think that
They have to know them.
Well, that's
Well, the lowest energy state is fundamental, right?
but what is the slowest vibration of hydrogen that's possible? Like
Yeah,
even
well, it's
theoretically.
whatever would make hydrogen bond or break its bonds. That's those
Like the
are the
ionization
states.
line?
Yes, that's the point. That's the prime resonant frequency, whatever is going to make it bond or break its bonds. They know what those are. They know those for all.
Boom, right there. That's the key. That's the resonant frequency, the tonal resonant frequency of any element is where it will break the bonds, the ionic threshold. Is that what Milo just said there? I think. And it's crucial. It's everything to it. And shout out to John and Nancy Hutchinson. They actually, I have to go back into one of my interviews with them where I asked them how they were measuring and recording these specific resonant frequencies, and they disclosed their method with it. Hey, shout out Mike. Appreciate you, brother. And like Terrence said right there, and the key part is it's what breaks down the tonal resonant frequency, just like with glass. Everyone's seen the video where you hit that certain note and glass shatters, right? It's breaking the bonds of the molecules, and that is exactly what you need to break the covalent bonds, and that gives you the over unity, specifically with hydrogen production through electrolysis and putting in that harmonic tone, that resonant frequency tone of hydrogen, which will break its bonds with water with the smallest amount of energy input needed and give you unlimited free fuel from water. And that is potentially exactly what Stanley Meyer figured out, as well as many others. And yeah, shout out to Terrence Howard. He's on it. He knows about it. And it's definitely a thing. And it's something I am working on as well. And will be releasing more information on at a later date. Oops, sorry. Shout out Chris Zazula. There you go. Oops. Oh, there we go. Add that as moderator. Everyone becomes a moderator. Now I've done that. Play the last minute here and probably wrap this up.
All of the individual elements, but they're not sharing that information because I think they don't want you to be able to use frequency to generate and create any system, because you don't need the element itself. All you need to do is create the condition.
I've wondered about that, and this is my most far out idea. But I'm like, if all of this is true, so this is prediction time. If this is so, I hate to use the word true because like whatever. But if this is so, if this is an accurate representation of nature, if there is truly an ether that's where it's vibrational or it's rotational or it's angular momentum is somehow the thing that gives rise to an element, as opposed to there being a thing that is the element. Like if it's an organizational structure, then you should be able to just take sound waves and create the thing.
You can.
Like
I don't think sound is the right word, but
Sound-
you should
no,
be able to
sound-
vibrate the substance.
electromagnetic.
No, sound waves, frequency. God said, let there be light, and there came to be light. And the first thing was the word. The word,
The vibrations.
light. comes
Vibrations.
from
I'll go with
sound.
vibes.
Vibrations,
Vibes.
okay.
Yeah.
Vibration
I got you.
hates light.
So what does that mean though? Like for you? Because Shiloh I'm sure that Shiloh has.
Well, I just think that sound, for all of the nerds out there, like sound is a particular kind of vibration that atoms do with one another.
Okay.
It requires a concert of atoms, essentially. Whereas light is some subatomic structure.
That only requires a concert of two atoms.
Yeah. And there's other, like heat is a different kind of vibration of the atom. Right? There's all these different vibes. Like I'm down with saying everything is vibes for sure. That makes perfect sense to me. But there are different kinds of vibes.
It's all temperature. It's all tempo. It's all repetitive and according to a frequency. How often does this repetition take place? Everything comes back down to how often this change or this impulse takes place. How often is this wave created, and what that does in moving something.
That's right.
That's what Tesla said. If you want to understand the universe, you got to think in terms of energy, waves, and frequency. Energy, waves, and frequency. And he didn't have the wave conjugations. He actually believed in the idea of straight lines. That was the thing where him and Walter Russell would fall out with, because they were very good friends. And Nikola Tesla was like, you need to take all of your work and put it into a capsule, a time capsule, and keep it there for 1,000 years, and then bring it out. And in 1,000 years, they'll be ready to understand what you're saying to them.
I say 100 years, and the time is now, so it needs to come out. And that's why we cover lots of Walter Russell's work. And here again, I'm just going to show cosmic vibrations from the Rosicrucian order. I've shown it a few times before, and they're showing how many times vibrations per second and your octave scale and what you're getting out of it. Everything is vibration. And here we have our colors, our light. And yeah, bang on with what they were discussing. Shout out to Demystify Sci. Shout out to Terrence Howard. And hopefully one day I'll have the pleasure of talking with him, and should be doing an episode with Demystify Sci again here within the next month or so. Appreciate it, everyone. Thank you all. Have a blessed rest of your weekend, and hopefully see you all on the next one. Ta-ta.
You crazy mother. Yeah.
It's just Bernie!
Hey, Bernie, just like last week, huh?
Weekend at Bernie's.